Okay, let's talk about how to find asymptotes of a tangent graph. So first I'm just going to start with the parent, so I'm not exactly sure the question that needs answering. So with the parent, the asymptote is at the undefined value. Because if we calculate the tangent at pi over 2, it does end up undefined. So what you get is these points in the parent function that give you this portion of the graph, and then you continue the pattern with 3 points in between, and then you would have your next asymptote. The distance between any two asymptotes should be one cycle of the tangent graph, so they should be separated by a period. So what this means when we are graphing a tangent function that has transformations, like this one here, this one has this a and this b value. If you make your chart like normal, okay, you'll see that like pi over 2, the x values are getting horizontally compressed by 1/3, so that pi over 2 is becoming pi over 6. The y value is still undefined. That tells me now that that's where my asymptote is. So each time I'm getting that undefined value, that's where my asymptote is. And I expect 3 points on the tangent graph between each of my asymptotes, because that's the way that we are working out the graph. So that's how you would want to figure out where the asymptote is. If you're talking about finding the asymptote when writing equations, let's look down here at this example. When we look at this, we would first find the other values, the a, the b, and the k, and then to figure out the h value, we're kind of using the asymptote to help us figure that out. Notice that the asymptote in the picture is at pi over 12. So we know one thing that could have happened is from our normal parent function where we have pi over 2 as the undefined value, once it's transformed, we now know from the graph that that asymptote could end up at pi over 12. Because we had already found a b value of 3 for this graph, we know the x values are getting multiplied by 1/3, and then the mystery question becomes what's being added with them to make that asymptote show up at pi over 12. So we did 1/3 times pi over 2, because that would be the x value that's being transformed, and 1/3 is the transformation, and then this is the mystery shift, and this is where we know that the new asymptote is. And so that becomes pi over 6 plus h equals pi over 12, and we solve that equation by subtracting pi over 6 from both sides, and then that's how we got this h value. So I wasn't exactly sure about the question being asked, but this is how you'd find what h value should be in the equation from the graph, and then the way you would know to draw your asymptotes on the graph is every time this undefined section shows up, and you could look at that in the points transformed to another graph. If you're not doing point transformation and you're just graphing by what it looks like, basically this should be one period of the graph every time, and that asymptote should happen halfway between the period. But then it could get shifted left or right, so that's why we have to adjust our starting point appropriately. So if you start wherever your shift is, so for example, let's say I had tan 2x minus pi over 4 plus 1. So when I go to plot my points, my midline's at 1. So wherever my graph is, where 1 is where I expect the middle points to be. Okay. And then I expect the points to be spread out by a factor of 2. So this is my normal parent function value of points. The 5 points that I would go through. So I want to go through those 5 points, but this time my shift is pi over 4. So instead of starting at 0, I'm starting at pi over 4. Where that is on my graph, I always want to make this fourth mark out a period of the graph. And so because of this 2 causing a horizontal compression, the period of this tangent graph is going to be pi over 2. I would put pi over 2 here. I would then figure out what 1/4 of pi over 2 is to understand how to number all the points on my graph here. And those would be eighths. 2 pi over 8 would be pi over 4, 3 pi over 8, 4 pi over 8, and then I'm just going to kind of continue 5 pi over 8, 6 pi over 8 would be 3 pi over 4, etc. And then I would go ahead and put these points on there. But again, remember now, your starting point is pi over 4 to the right. That's 2 marks to the right. This is now my starting point. That's the point I want to be on the midline. The next point is above it because I haven't reflected, but it's above it by 2. Then I have my asymptote. The next point is below that midline by 2, then back up to the midline. And this is that portion of the graph I'm seeing. And then I could extend these points so that I could get the other asymptotes and picture of the graph. So how to find the asymptote depends on whether you're graphing by just knowing where these 5 points are and following some patterns of transformations, or if you want to use the table of points.